Hello developers! So, we're back with the second part of the 10th day of 2024 Advent Code. So, I have an idea. So, this will either work or this video will never see the light of day. The idea that I'm expanding on, and I already did most of it in day one, is that we are going through all of the combinations. Let's see how our count trailhead score function works once more. So we have a queue and we're putting all of the neighbors that are in the correct direction, all the good neighbors. So in our case, in the initial case, where was it? So we're gonna put both these ones. This one will put these two, but this one will also put these two and these two. So these two will be inserted twice, and I did that intentionally. So in essence, we will go all the possible ways. I won't say, well, this 2 is already here, we don't need to put it, it doesn't matter how we got here. Because now in part 2, it does matter how we got here. So, if I am correct, so now instead of the score, we're calculating something called the rating. I think so. Yeah. I will just copy this over and implement a function that is totally similar to this, that says count trailhead rating. And instead of having all the possible destinations that we get, I will just have a counter that I will set to 0. Because if we get to a destination, then we get to there in a unique way, because each of the combinations goes different. We might have in our queue, this value will be 2 times, but once it got from the up one and once it got from the left one. So that means that if we get somewhere, and note that with having 2 2s, we will process them twice, which means that these 3 will get there twice, this 4 will get there twice, and this 5 will get there a number of times. Because note that we can go 1, 2, 3, 4, we can go 1, 2, 3, 4, or we can go 1, 2, 3, 4, or we can go 1, 2, 3, 4. All of those 4 or something like that paths are equally valid, and we will get to the 4 times, which means we will have 4 fours inside our queue. It is an overhead. In the first case, we just needed to get there once, and it was good enough. But for the second part, I think that if we just increase the counter here, if we got to a 9, we can have something that looks like a solution. So we're not returning the size of the destinations, we will just return the counter. And of course, the code itself of part 2 will be identical to part 1, when we're just getting the trailheads. Of course, we're going to call these elevations. We're getting all the trailheads, and then instead of calculating their score, we're calculating their rating. Let's check that we do have the small input. No, we have the big one. The small input, which had 36 score, I think. It has a rating of 81, and the correct value for the rating was 81. Let's see it on the big input. And it's 1764. Let's see if this is the correct value. And it is. So this time We benefited from a nice design of something so that we can reuse it for something else. We used it to get the score and then we reused it to get the rating. We were aware when I designed the score mechanism that we are kind of overdoing it. We can have duplicates. We will redo some paths. But that was okay because that was what was actually needed for the second part. If it wasn't needed and it was fast enough, I would have left it there because extremely performant design is usually extremely specific design. I would have left this if it's performant enough. If we had a performance problem, as we will have in later tasks, I would go back and then optimize it, but always start with a kind of a baseline solution that you can actually understand. Otherwise, you're getting to a solution that is kind of clever, that if it has a bug, it's not always obvious what it does. I hope that I was able to explain why I did the things I did and how I got lucky for the second part and just changed a single line of code and gotten the correct solution. Mesh the nice buttons, don't touch the bad button, and keep developing.